Let me now introduce Anton Seimon. This is actually the second time Anton has participated in our morning coffee series, and his last session was so popular, we were after him right away to do this again. Anton is a noted climate scientist. He is affiliated with the Bard Graduate Center for Climate Science and Policy. He's a National Geographic Explorer. And I always like to remind people that Anton and his wife, Tracy, who's a scientist in her own right, are also like to chase tornadoes during their vacation time, which I think is one of the coolest things. So, Anton, I'm going to turn it over to you. And thank you again for doing this for us, by the way. And I'll turn it over to you now.
All right. Good morning, everyone. Afternoon for some of you. Thanks so much, Bob and Kate. It's great to be here again with the Partners for Climate Action. I'm going to talk about obviously a very sober and serious topic today, but it's not all terrible news, and I think we should remember that and sort of keep that in mind. So let's see, well, if we can make everything work smoothly and flawlessly. All right. So I'll start with a view of the Hudson Valley from last week. This is really just last week here, which is quite remarkable. This is the kind of thing that we experience here where we're living. Sorry, I need to do a little more configurations here. Hold on. Okay. So what am I talking about? This is a view looking southwest from our house across the Hudson Valley towards the Catskills. And the amazing thing about this is whoops, sorry, we'll try to set up a time lapse. Don't know why it's being a little cantankerous with me. Hold on one sec. All right. I'm just getting used to how this one particular thing works here. We'll just do it manually. There we go. Okay. So we live in an amazing place. It's gorgeous here, an incredibly dynamic climate. We go through all four seasons with very distinct marked characteristics. We're used to it. Many of us have grown up here. Some people have only moved here relatively recently. But scenes like this, absolutely breathtaking, are quite amazing and quite common, actually, if you've got a place with a nice vantage point. So it's quite amazing. Take a breath and sort of remember just how wonderful it is here, because we'll talk about some serious and rather negative things at times today, but I want to also keep in mind that our base state is pretty damn wonderful. So in this presentation, my goal here is to really make global climate change understand in our very local context of the Hudson Valley, all the way, say, down to New York City area as well. We'll look at these changes on a seasonal basis. I found it kind of helpful to break it down by season that way. And there's some important context to remember that I'll sort of remind you of as we go through parts of the talk. The physical geography and the biogeography of the region are very distinct, especially as you go uphill in elevation. You move up in the Catskills or Berkshires and Taconics, the Hudson Highlands. Very different ecology and very different climatic conditions. We'll see that with things like snowfall patterns, just how remarkably different they can be as a function of elevation and where we are, say, relative to major water bodies. Very important point I'll hammer home repeatedly is how temperature relates to hydrology, moisture in the atmosphere. And then what is El Nino, which is a climatic phenomenon we're experiencing right now, and how does that relate to climate change? Are they the same? Are they distinct? So we'll take a look at that. A little bit about my relevant experience. I won't read through all of these things. I just want to sort of reinforce that I've got very deep experience living and working in this region. I love it here. You know, I found it incredibly rewarding, and as a scientist, it's a very dynamic place to live and work because you can really see things on a regular basis. A view outside many of your windows right now will show a snowstorm in progress. That's the kind of thing that I think is quite fantastic about living up here. So yeah, and I work sort of at a very high level, like with scientists at the National Center for Atmospheric Research, which is in Boulder, Colorado. But I also, you know, I feel like I've got my finger on the pulse. I'm very much sort of immersed in these things, both here and abroad in different projects. So the big picture, I'm sure you're all well aware of this. If you want to look at, say, global temperatures over the past 170 years, the earlier part here is a reconstruction. But as you go towards the present here, and this is a temperature scale in degrees centigrade, the different colors represent different analysis centers around the world, and they all seem to be saying the same thing. There's some differences of opinion sort of early on, but as you go through the 20th century, there's strong convergence. They're all measuring the same changes in temperature, which is inexorably upward, with some up and down variations from year to year. But in general, you can see this very marked global warming signal. It's very real, it's unquestioned, it's observed, and we're already experiencing very significant impacts from this type of warming. Now, this is like taking the pulse of, the temperature of the whole planet, the atmosphere of the planet. How do you actually make this local? How do you make it understandable? So again, one of the key points I'm going to hammer away here is that an incredibly important takeaway about a warming climate. It's not actually the temperature that's the biggest problem. It's what temperature does to the carrying capacity of air in terms of moisture. It's because temperature, as it increases in a relatively, say, straight line, actually has an exponential effect on increasing the moisture carrying capacity of air. This means that, say, a thunderstorm in a warmer climate can deliver more rainfall in a shorter period of time. But similarly, a dry period under a warmer climate can suck moisture out of a landscape, suck moisture out of vegetation more rapidly as well. And for that first degree of temperature rise, you'll notice that there's sort of 7% change type of thing. But then as you go through sort of successive degrees, there's a compound effect. It's compound interest, if you would. And so we see a very rapid amplification of these effects as changes continue to occur. As the temperature warms around the planet, we see more and more effects, especially on the hydrological side. Okay. So we'll do a survey of the seasons. Winter, oh my gosh, what a wonderful, extraordinary time. It's a bit fearsome. In the past, winters were, in general, much more severe than they've become recently. That can be seen as being, a kind of a benefit of sorts of climate change for some. A lot of people are sort of daunted and frightened by how cold it used to be. So that's not a time lapse. That's actually real time with just trees shedding snow following snowfall right here in the valley. It can be breathtakingly beautiful and crisp. But there are all sorts of changes that we are already seeing and others that we can expect to see over time as a consequence of this warming of the climate overall. We're already seeing a greater rain fraction in winter storms. We still get plenty of snowstorms, maybe not as many as I'd like, but certainly rainstorms are quite common, even in the highlands here, where, snowstorms certainly were dominant in the past. And with that rain also comes the growing likelihood that we'll see more serious ice storms. These two pictures below are local views here in Columbia County following ice storms. Trend of more frequent high-intensity nor'easter storms. We have a nor'easter in progress right now. Not a particularly severe one, but down in the lower Hudson Valley, they're going to get a good 10, 12 inches of snow, probably in a narrow band across Orange and Putnam counties, maybe Southern Dutchess County, Northern Westchester. Milder temperatures overall, boy, are we seeing that. Just last week, we had 2 record high temperatures here. Much of the Hudson Valley got up around 60 in Albany, which in, 10th of February, that was really quite something. We're seeing things like inconsistent ice formation on water bodies. Those of you who have been out and about in the valley in the last week have probably seen the ice melt on many ponds, certainly on the Hudson as well. That's weird for early February, but here we are. Things are really happening like this. And we have a changing weather variability overall. So let's look at some of those geographical differences. Just to orient you, this is a snapshot of the Albany National Weather Service office's forecasting area. So this is Massachusetts border down here. This is the Capital District of New York State. And this goes down to Interstate 84 in Southern Dutchess, Northern Putnam County area here. That gives you an idea. There's 87, the New York State Thruway along the Hudson River. So this is Adirondack region. This shows annual rainfall from observers, long-term rainfall for, say, average over the last 30 years. Generally, you see rainfall varying from about 43 inches in the Albany area up to maybe 59, 60 up here in southern Green Mountains and the Catskill summits. It's a very moist climate, but there's not that much variation over distance. Take a look at snowfall in contrast. Very, very different. Snowfall along the Hudson River here is just 20 inches or so. It's shown here down around from Kingston on south. Meanwhile, these Highland areas have much, much more snow. So you can see that kind of difference across space. And that as the climate changes, this is the kind of thing that's going to be experienced quite dramatically. How climate change is experienced will really vary depending on where you are. So here's an example just from an individual snowstorm. This was middle of March last year, long duration storm, put out a pretty monumental snowfall, 2 to 3 feet in these reddish areas that you see here. But look here along the Hudson River, right here by Kingston, 0.1 inches, whereas at my house here, about 25 miles away, 31 inches. All right? So you have this enormous spectrum. I'll point out that had the same storm occurred 100 years ago with an overall cooler climate, Kingston would probably be in the 10-inch range back then, just 100 years ago. So we're already seeing manifestations like this. Similarly, down towards the coast, New York City area, there would have been a greater snowfall total. It's logical to expect that. Now, there's some really strange anomalous weather that we're experiencing. The last 3 weeks, I think, is a fantastic example of this. Up at my house, I run a weather station. I've done that for 7 years now. And we had 11 straight days of low clouds and fog here. I mean, as gloomy as it comes, though we had beautiful snow cover on my hilltop, at least it made it bright that way. But here, this is a relative humidity sensor that shows humidity above 97% for 11 straight days. I didn't think this would ever happen in this area. This is the solar radiation recorder. You can kind of see the daily peaks in solar radiation dropping to 0 at night. But here, 11 straight days, hardly any solar radiation. This did a number on our solar credits. We have a solar array on the roof, and we weren't getting much energy at all. But what's that followed by? 7 straight days here of almost perfect sunshine. This is extremely variable, very strange weather. Is this a manifestation? Is this a manifestation of climate change? In this case, I'd say almost certainly not. This is very likely a manifestation of the El Nino event that's ongoing right now, where we, at this particular latitude that we live, we can sometimes get sort of hung up between a jet stream to our north and another one to our south. You get very stagnant weather between those two corridors of much more active weather. And as a consequence, you can have this very strange progression of weather. So it's very important to try to understand things. Not everything is going to be associated with climate change. There are other factors that can also give us strange weather. So a quick word about El Nino. It's important to understand that El Nino is part of a global weather machine, which is the largest source of year-to-year variability in global climatic conditions. And it has to do with sea conditions, the sea surface temperatures in the tropical Pacific Ocean. Here are the Americas, over here on the right side of the globe. In October 2022, this is a plot showing temperature anomalies relative to long-term normals of the sea surface. And you see the tropical Pacific characterized by these blue shades. Switch a year later, and you see now it's dominated by these red and orange shades. These are much warmer temperatures. This is the El Nino effect being manifested. Because there's so much heat stored in the tropical Pacific Ocean, this has global effects. It sort of radiates and propagates away from the tropical Pacific and can influence weather in far-flung locations, including our own Hudson Valley. And if you look at a time series going back in time, say of the El Ninos and La Ninas, the red anomalies here are the El Nino events. The blue are the converse, the La Ninas. And we see we just transitioned in the last year from a very strong La Nina to a moderate strength El Nino. That's where we are right now. But you can see in the past, there have been other events like this. And the last time we had a spell of cloudy weather that compares, in my recollection, as well as in high school down here in 1983. So these things do recur. This is part of normal climatic variability, not necessarily climate change. However, an open question is, well, what does climate change actually mean for the El Nino phenomenon itself? That's another question. Moving to spring, you can see the forest starting to breathe. This is following a rainstorm. As the rain is clearing, the forest is just pumping moisture back in the atmosphere. Everything comes back to life. Wonderful, wonderful time of year around here as you see the greening of the landscape. But we're certainly seeing that spring seems to be happening earlier and earlier, and this is manifested in several different ways. We see significantly earlier flowering and the leaf out of the regional vegetation. The forest is going green much earlier than it used to, say again, about 100 years ago and earlier than that. As a result, we also see an earlier emergence of species, the arrival of migrant birds and other species. We're possibly seeing an increase in severe thunderstorm occurrence. That simply goes with a warmer atmosphere is going to be doing that to you. But regarding the species, really interesting work's been done here by a team, including scientists at Hawthorne Valley, right here in the valley, just down the Taconic Parkway from me. And they compared historical data on phenological changes. That's the timing of natural events. In this case, looking at plant species when they first flower in the springtime from the past relative to the present. And you'll see that comparing, say, the middle 1800s here to a more recent period, say, in last decade, plants flowered 10.5 days earlier in the contemporary period and leafed out 19 days earlier than they used to. These are huge, huge changes. And you can also see it manifested in things like to take a walk in the woods in March, you may hear spring peepers when you only used to hear spring peepers much later, you know, those chirping frogs that are the real harbingers of the coming of the warm weather. Generally, I'm not going to draw upon peer-reviewed studies like that. I just wanted a particular case because it is so local to what we're talking about. But we're also seeing, as we learned in this past year, smoke from Canadian wildfires, you know, events very far away can have a very marked local impact. So many of us experienced this back in June. Oh my gosh, it was unbelievable. There was so much burning in Canada that we've never seen before. This was because of very warm, very dry conditions and a largely snowless winter that didn't give the forest the normal moisture that they would have. And if you look at the area, a burned area in Canada, these are millions of acres, okay? These are enormous areas. I think to give you an idea, I think the Adirondack Park is 6 million acres, if I'm not mistaken. Gives you a sense of how large an area we're talking about here. Well, what happened in 2023 is just so unprecedented, it's absolutely jaw-dropping. Well, there are many, many serious consequences to that. Now, for one thing is many of us became familiar with maps like this that were getting published, say, by the news media on a daily basis back in June. This is the thickness of the smoke over the landscape, the vertically integrated smoke. And this is very unhealthy air, lots of particulates that are very deleterious to human health. But there are effects that are manifested in other ways. This is the monthly measurement of the electrical output from the solar panels on the roof of my house. Look here in the month of June, this dip relative to kind of what you'd expect to be the annual peak. This is this very smoky period. And we lost solar power generating capacity as a consequence of persistent smokiness. This is something which, well, as these fires become more and more common and more widespread, we may be dealing with some things here. So there's kind of our own efforts to rely on renewable energy can be taking a hit because of things that one might not have foreseen. Other things, you know, the Bronx Zoo or the New York City animal parks were closed as well at that time due to bad air quality. This is for the animals as much as for the humans. Everyone had to go indoors. Summer, wow, summer. It's such a wonderful time of year. So dramatic in the Hudson Valley. We're all outdoors. We're enjoying a beautiful evening barbecue, and then something like this comes rolling in. a big severe thunderstorm rolls in, can be incredibly dramatic. And the point here is that the thunderstorms of the past are not the same as the thunderstorms of the future, because the ones in the future, and we're already starting to see that now, can simply deliver that much more rain in a short period of time. Because as that atmosphere is warming, it's carrying more moisture and can deliver that moisture much more furiously. That has very, very severe consequences. And we'll look at some examples of that here. So, how's this manifest? Okay, obviously increasing heat wave frequency and severity, that's pretty obvious, and I won't dwell on that. But then you can also get things like greater desiccation. You know, when it's hot, you suck moisture out of the landscape more rapidly. You may also see things like a wildfire hazard that may increase. But this is really the biggest concern, I'd say, in the Hudson Valley for the summertime period, of these intensifying rainfall rates. We're seeing a rapidly increasing flash flood frequency. Overwhelmed infrastructure, slope failures, and landslides will be more and more common. And this is becoming an almost annual occurrence. There's several events here, and breaking news from the New York Times, flooding shutting down, the New York City subways and things like that, brutal flooding in the city. There are very real consequences here. We're experiencing them. Then in July this last year, major floods here in the lower Hudson Valley, peaking around West Point and Cornwall, this area up into Vermont. It's making national news headlines here, deservedly so. But here are some notes that I sent around before the flood happened. This is, in the hours leading up to this event actually unfolding in the Hudson Valley. And I highlighted some of the factors that said that this was a very, very serious situation. It's likely to have major impact. And one of the things I'll say, climate change, I said very much a factor here. Had an identical weather system occurred at the same time over the same domain, the water vapor content of the atmosphere would be significantly lower. We can actually quantify that. Now, what was I looking at? This is a plot from a weather forecasting model that shows the moisture content of the atmosphere. Here's our region here. This is Connecticut and Long Island. This is the morning of the 10th of July. And it's showing these values of moisture in the atmosphere way at the right side of the scale here. About 2.5 inches of moisture is shown in a vertical column. Well, if we actually look at weather balloon observations going back 70 years, we've got, these reliable measurements of the actual moisture content of the atmosphere. Values up in this range, they're way here on the right side of the plot. There's almost no precedent for this much moisture to be held in the atmosphere. Therefore, we should not be surprised when you have these catastrophic floods that dwarf anything that we've actually seen in recent memory. Here are some scenes around Cornwall, New York. Unfortunately, right here, down the valley from us. And Route 218, north of West Point, is still closed right now. It's expected to be closed until July. But one wonders, when you see the magnitude of the type of destruction here along 218, is this actually even going to be rebuilt at all? Transitioning to fall, my gosh, what a wonderful time of year. And another one of these unbelievable Hudson Valley sunsets. A view again looking southwest towards the Catskills. Magical time of year, but boy, it comes with its own risks as well, as we'll see. There's some strange things going on in the fall. One of which is that we're seeing things like this delay in the leaf drop. We talked about leaf out occurring earlier, that trees are going green towards the end of March now into April, whereas it used to be well into April. But look at this here. This is Tolman Park in Rockland County, so north of New York City. This is the day after Thanksgiving, a couple of years ago, right? The leaves are actually dropping from the trees after Thanksgiving. This used to happen more closer to Halloween, 31st of October. So we are seeing changes like this. Now, in terms of more serious things, the increasing tropical cyclone or hurricane impacts, I think we're also going to be seeing that. We typically don't have to deal with like full-fledged hurricanes here in the valley, but the rainstorms that are associated with a dying tropical cyclone, they are very, very severe as well. I mentioned wildfires. This is a view of the old Tappan Zee Bridge here, Lower Hudson Valley. That's a forest fire in Tolman Park, the same place I just showed you with the leaf drop going on. This is November of 2013. A forest fire in the suburbs of New York City. Again, you get a dry spell, things can ignite. And we are seeing things like these smoke outbreaks. They last into September now. You get huge outbreaks of fire in the west coast of the US. A few days later, yet this is all smoke you're seeing intermingled with cloud over our region as well. And these recurrent floods just keeps happening. 29th of September this last year, another historic rainfall in New York City with major, major impacts. And unfortunately, this is something that we just have to deal with, and our infrastructure is not really well equipped to handle it. Final word about global mean sea level. Sea level around the world, as climate warms and ice melts from polar regions and high mountain glaciers, sea levels are rising. And what's more, the sea level rise is accelerating. It's now about almost 0.5 millimeter per year. Sorry, 5 millimeters per year, which is, about 2 inches per decade almost that we're talking about. Okay. Now, right here, the Hudson River itself is prone to that sea level rise because it's an estuary. The Hudson is tidal all the way up to Troy. And what we see here is this is a very long record of water levels measured at the Battery in Lower Manhattan, going back to the 1850s. The total change shown here on this vertical scale is about 2 feet. Oh, sorry, 4 feet. From -2 feet, 0, +2 feet. We're up here now, okay? And look at the most recent decade. You can see a clear acceleration here. We're actually deviating away from the long-term trend. The sea level is rising more rapidly. This is having significant impacts along the Hudson River already, and in the future, it could be very, very severe indeed. We're already seeing things like, when there are major storms, there are interruptions of train service along the Hudson. But it seems almost inevitable that over time, a few decades from now, these rail lines will be destroyed. There are going to be events that will simply overwhelm the rail lines. They'll be undercut, and it'll be very, very expensive to relocate or raise those railway lines, something that we have to be thinking about. So what do we have in New York State? We have the most progressive climate legislation in the country. This is, it's great to be in New York because the winds are at our back politically, so to speak. We have a very progressive government administration who recognizes the seriousness. A lot of this is as a consequence of Superstorm Sandy back in 2012, which did so many billions of dollars of damage and killed, more than 100 people downstate. Very, very serious event. And from that, we have landmark legislation. And this quote from Governor Hochul, I think, is very telling that, people at the highest levels of government recognize the severity of what we're dealing with. So the final slide is just some useful sources for keeping current on climate science. Kate is going to put these, obviously I can make an exhaustive list, but if you just had a few things that you wanted to go to keep up to date on things, these are sources that I can recommend. Kate's putting them in the chat, so you can copy them down from there if you want. But I'll leave the rest of the time for questions, and so thank you very much. Bob, you're muted.
Okay, thank you. That's excellent. Thank you so much. I want to remind everybody, if you have questions, do put them in the chat, and we're going to do our best to get everyone's questions answered. I want to start with just a few. These are questions from folks here in the office at Partners for Climate Action. Just first of all, so what you've laid out for us, a lot of it is very sobering. And I always like to ask the question, what do we have to be optimistic about? Is there any kind of silver lining in any of this, or some reason why maybe we can be happy that we're here in the Hudson Valley and not somewhere else?
Yeah, I think that, the Hudson Valley is actually a very good place to be in the context of climate change. We've got lots of these upland areas. We can always escape to cool places and go hiking, walking in the woods, or even, live in a residence, like I do. here on our hilltop last August, the maximum temperature recorded the entire month was 77 degrees. You know, that's, we don't have air conditioning, that type of thing. So you can still find some sort of very favorable conditions like that. Converse of that as well, the winters are that much more severe. So you can kind of pick and choose, if you would, what the type of environment you'd like to be in. One thing we have to recognize increasingly in the Hudson Valley is I think we are going to be seen as a very desirable location to be in context of climate change. So a lot of people are going to want to move here. All right. That'll do great things to your property values. Unfortunately, may not be so good for your property taxes and other things like that. But yeah, there may be increasing competition for that space, for land. And so doing things like really safeguarding our protected areas, the Columbia Land Conservancy, other organizations like that are already wonderful organizations that ensure we maintain those big green spaces, between all the areas where people are living or farming or doing, or urbanization is taking place. Those resources will remain incredibly valuable to us. We obviously need to do things like safeguard the mountain water towers, the Catskill Highlands, the Berkshires, the Taconics, Hudson Highlands. These are places where more rainfall and snowfall occurs. We really are going to need that water to sustain our livelihoods and so many other things, industry, looking forward. So protecting and preserving those places is really, really important. That means protecting them from things like forest fires. You get a big forest fire, it effectively clears the land and water runs off much more readily versus being absorbed into the landscape. So if you want to retain water in the landscape, you need to retain the forest on that landscape as well. So, yeah, as mentioned, winters are, milder than they used to be. A lot of people actually found that to be a very favorable thing. We can, rage about the causes of that, but, it is a reality. A sub-zero day is a pretty brutal thing, and they've become very, very rare indeed. So, maybe that can be seen as a benefit. Obviously, the converse are the heat waves in the summer, which tend to be longer and more intense. And one of these days, we're going to see things like 110-degree temperature in New York City. It's never happened before. The all-time temperature is 106. And that's frightening. But since we know it's coming, I think we can prepare for it.
Mm-hmm. Great, thank you. You talked about our forests. Can you give us a snapshot of how climate change might be affecting our native trees and other native vegetation in this region?
Well, forests are in such a state of flux right now. We're seeing an enormous turnover in species because of things like pathogens coming. We lost most of the Dutch elms back. Then we lost, the emerald ash borer has come. And we lost the chestnuts. There've been these major sort of pandemics of forest species this way. And there is this turnover and replacement going on. But climate change looks to be an accelerator or an enhancer of some of these processes. Fire is a very obvious threat, but fire is unlikely to sort of be universal, spread everywhere, right? Much more piecemeal type of occurrence. But things like pathogens that are favored by, say, a warming climate or wetting climate like that, those are going to register some very major impacts. Some of those things we can see coming. Other things, they surprise us when they happen. It's somewhat out of the realm of my expertise. There are people I know listening in who really do have that knowledge. Those would be great webinar speakers, I think, as well to host here in future. So just in general, it's kind of interesting to see, speaking as a scientist, wow, leaf out is occurring earlier and leaf drop is occurring later. But what does that do to the whole forest health itself? Is this necessarily a good thing? Don't know. It sounds like there may be stresses involved in that as well. So there's a whole host of consequences. And I think the most important thing is simply to recognize that we are living in a state of flux, that, the sense of stasis, that there was kind of a level baseline that would be maintained, or perhaps um, that there was variability around a baseline as experienced in the past. That's been thrown out the window. Very much we are now, living in a period where there are marked trends and then there's short-term shocks. And those shocks can be very, very severe. Like, when an entire species of tree essentially gets suddenly wiped out of the forest ecosystem. Wow, there are very widespread consequences of things like that.
Mm-hmm. Yes, and equal consequences for the animals and the fish that call this area home as well. Yes. Um, okay. Wondering, in your opinion, I mean, we do have the Climate Act, which I celebrate with you. It's not fully funded. Um, and I think that there's all of these shifts that we're seeing are requiring increased action on the part of our local municipalities and the state government. Can you say a little about kind of your short list of what you think towns and the state need to be paying attention to, given just the increase in precipitation, et cetera?
Fortifying infrastructure, number one. The infrastructure that we've all inherited, like if you say live in an urbanized area, there are things like, all the streets have storm drains, okay? Your own basements, your basement in your house may have a sump pump, a bunch of things like this. Well, these things were engineered under expectations of climates that no longer exist, okay? Those are climates of the past. So, for example, the entire New York City drainage network, which, the sewer system to take stormwater runoff, is designed for rainfall up to a certain level. We are routinely exceeding that level, okay? When that happens, it becomes overwhelmed. So if the water can't go down the drain, where does it go? It goes down the street, into the storefronts, into residences, floods basements, that type of thing. And that's because, it cannot, the drainage systems cannot accommodate the capacity that we actually are dealing with these days. So that is a very obvious thing that needs to be updated and changed. It's also very, very expensive to do so. Obviously, we're talking about, moving concrete and, replacing it. And then, so what is the appropriate drainage system? Do we actually have a good sense of really, how robust this needs to be? So there are a whole bunch of questions like this. So the engineering community really needs to be talking to the climate science community, need to be talking to the politicians who are going to have to fund this all. And we have to accept, as taxpayers, that we will ultimately be paying for these things. Now, we can choose to hope for the best and wait until, push becomes shove, but that always turns out to be far, far more expensive. So one of the things that the Climate Act does allow us to do, it sort of helps municipalities sort of take that initial plunge and actually start making those needed investments and doing a very thorough assessment, recognizing the vulnerabilities that we have in our infrastructure relative to climate change. So I think that these are some of the most fundamental things, but I'll point out they're also very actionable. We can really do something about it. And we actually have foresight about it. We don't actually have to wait till the disaster hits to recognize that there's a problem.
Mm-hmm. Great, great. Um, Question for you about geoengineering as a potential solution for any of this. What thoughts do you have on geoengineering as a possible remedy?
Yeah. Geoengineering in this context would be specific actions, typically applying technologies to try to counter climate change. Typically done, sometimes it can be done at a relatively local level. One example of a local level is fly over New York City these days, and you see many of the rooftops are very bright light colors, like light gray or white even, whereas there used to be that black tar that you'd see. That black color was absorbing a huge amount of sunlight and artificially heating the city, all right? So if you actually replace the dark surfaces with lighter surfaces that are more reflective, there's a local benefit for something like that. That's a geoengineering solution at very local scales. But geoengineering is also being proposed and in some cases initially conducted at global scales as well. The idea being to try to turn down Earth's thermostat itself. We accidentally, through greenhouse gas emissions and deforestation, have turned the thermostat up, okay? So if we did that accidentally, can we actually deliberately turn it the other way? So some of the strategies proposed, for example, are mimicking volcanic eruptions. You know, giant volcanic eruption will throw a huge quantity of dust up very high in the atmosphere, will spread around the world, and will reflect some of the sunlight before it ever reaches the Earth. That has a cooling effect. It doesn't last very long, though, because within a couple of years, all that dust eventually sediments back down to the surface of the Earth. We go back right to where we were. But there are serious plans afoot to see if humans can actually mimic what a volcano does by injecting great quantities of dust of a similar composition up into the stratosphere, very high in the atmosphere, to achieve a similar type of cooling effect. It's estimated that this would only cost a few tens of billions of dollars a year to do once they hone the technologies, which seems to be an incredibly low price to pay for cooling the Earth. But there are huge problems associated with that. And so the problems are all the unintended consequences that come with it. All right. It's one thing when we know what we want to achieve by, say, cooling the climate. But then when we run, say, climate models where we simulate doing these interventions, as we call them, versus not doing them, we found all sorts of strange side effects and things that may be very unwelcome. Rainfall reduction in the Amazon or the Indian monsoon may stop happening, something like that. These could potentially be catastrophic events in different parts of the world. So geoengineering is a cause for much hope that maybe we can fix climate change, so to speak, but it's so laden with uncertainties and risks that it seems that it would be a terrible choice to actually pursue it. So until the present, it's very much resided kind of in the realm of science fiction. Well, if the Earth ever really got in such a bad state with climate change, maybe we could resort to geoengineering solutions to do something about it. What's increasingly worrisome to me and other scientists who work in this field is that we seem to be rapidly getting closer to the day when people say we are at that point we actually need to start taking some of these actions, even though we don't really understand what the consequences are. That is something for great concern. So yeah, it's something definitely to keep an eye on. I think that we'll see increasing media coverage of it. And yeah, geoengineering is a reason for hope. It's also a reason for enormous concern. We'll sort of put it that way.
Great. Thank you. Okay, I'm going to turn to some of the questions that are coming in through the chat. A lot of our listeners want to ask about the effects of invasive species in the region. Do invasive species leaf out in the spring faster than non-natives? Is it a good idea to introduce more southern tree and native plants at this time to prepare for future warming trends? I don't know if you have thoughts about this. I know this is maybe out of your specific area of expertise, but any thoughts you might have?
Yeah. Again, this would be a fantastic topic for its own webinar, and I hope you pursue that, Bob. But in general, you can see it two ways. The invasive species and the species replacements are going to occur anyway, okay? So if we're somewhat fatalistic about that, there is something to be said, well, we can be proactive and perhaps maybe exert some degree of control over, well, what comes and populates and what it replaces. It's a bitter pill to swallow, though, that some, magnificent species, be it plants or animals, that we are used to being in an environment may over time become extirpated from this environment just because they are out of sync now with the climatic conditions that would supported them in the past. Those conditions will maybe not occur in future. We certainly see that like in the Western United States, where you've got these pathogens, bark beetles and things like that, that are infesting pine forests and, the other conifers. This is because it just, we're not seeing the cold waves of winter getting quite cold enough to actually wipe them out on an annual basis. The bugs keep coming back in greater and greater quantities, and enormous stands of forests are actually standing dead right now and becoming fuel wood for forest fires. You see that type of thing. So yeah, some kind of replacement that ensures that at least we retain forest function in that landscape would have been a great mitigation measure for that type of thing. Well, guess what? Once the forest burns, you have open meadows, new species will colonize, and the ones that are going to be favored are the ones adapted to the more contemporary climate. So, yeah, I think that this kind of turnover is inevitable. And in a selective way, if done strategically, perhaps enhancing migrations this way may be beneficial. But again, this is outside of my league. So, let's speak to the forest ecologists and get them here and fielding those questions. Thank you.
Well, folks will be happy to know we do have a couple of sessions lined up for our morning coffee series that focus specifically on forests and also ecological restoration in general. So there will be time in future meetings to cover that sort of thing. And also, I'll mention at the end of the call, we have our next two morning coffee series scheduled already. The next one will be March 12th. And we're lucky to have Vanessa Fagins-Turner, who is the new head of Environmental Advocates, New York, to come and talk about climate policy in New York State and kind of the state of climate in Albany, with a particular eye toward the budget and how that's playing out. So look for that on March 12th. Let's see here. We have a number of questions about winter in particular. One question is the lower snowfall in the lower Hudson elevations along the Hudson shoreline a result of warmer ocean and estuary temperatures?
I'll be honest, when I pulled up that map just yesterday, I retrieved from the Weather Service, I was astonished to see how low the annual snowfall is in that region. I think largely it is because being at the bottom of the valley, you're subject to what's called a rain shadow effect, which is to say, like, since most snowstorms are of this nor'easter variety, as we call them, winds blowing from the northeast, that means that air is coming across from highland terrain in northwest Connecticut, that air, that highland massif around Mount Everett, Mount Washington, southwest Massachusetts, blows downhill. And when air blows downhill, it tends to dry out somewhat. That's what we call a rain shadow. So the lee of the Rocky Mountains is a famous rain shadow, where the high parts of the Rockies get bountiful snow, but then as you go down to the plains to the east, there's a major reduction in moisture this way. So a similar thing happens on a much more localized scale here in the Hudson Valley. So that warming, and drying will do two things. It will take those marginal storms like the one we had in March, and you'll get wet snow or rain, whereas the highland areas flanking it will see snow. That's one factor. But then simply the amount of moisture that actually falls to earth will be lower than in the flanking highlands as well. But that said, yeah, I was quite struck that there's some places that only average 18 inches of snow. Up where I live, we probably average more like 90 inches of snow up here. It's a huge difference, because we're in viewing distance down to the valley there. So elevation is one thing. The Hudson River itself, in terms of being a warming effect, it's not quite, doesn't have quite enough thermal mass, I think, to be of consequence, except right at the immediate shorelines. It's generally less than a mile wide, And as such, I don't think that warming would be that pronounced as to change snow to rain in a majority of weather systems. So I think it's more the topographic influences that are more significant there than, say, the presence of the water bodies.
Mm-hmm. Great, great. We have a lot of questions about El Nino and La Nina, starting with the hope that you might be able to explain the difference between El Nino and.
Okay. As shown on my slide, we're talking about things that are occurring many, many thousands of miles away from here, but nonetheless can have a marked effect on climatic conditions and the variability of weather we'll experience, say, in a given season. La Nina is effectively the opposite of El Nino, and it's also kind of more like the normal state, which is where there's a cold tongue of water, relatively cold tongue of water along the equator in the eastern Pacific Ocean. Okay. And that is water that is upwelling from the deep near the coast of South America, and then it's blown by trade winds, it's blown westward with time. When you have an El Nino, for reasons that aren't fully comprehended, you have a breakdown of that normal situation, and a big body of water, of warm water, which develops on the western side of the Pacific Ocean, effectively sloshes eastward in the subsurface of the Pacific, and then emerges around Christmas time, normally when you have one of these events. Hence El Nino, which is a reference to the Christ child. You know, this goes back to the colonial days of Spanish colonialism about 500 years ago on the west coast of South America. Okay. And so an El Nino is when you have the sudden warming of the Pacific Ocean near the coast of South America that then sort of, propagates along the equator there. So much heat is liberated to the atmosphere that it does things like you see major eruptions of thunderstorms near the equator there where you don't normally see them so significantly. This in turn has effects on things like jet stream circulations very far away. And it's those ripples in the jet stream that then modulate the weather that we experience. So consider that, when you have the normal La Nina-like base state, you get, let's say, one type of jet stream configuration, well, a set of jet stream configurations giving us dynamic weather in these parts. Suddenly, you upend that when you have like what happened in the past year, as you went from a La Nina pattern to an El Nino pattern, you end up with an entirely different suite of jet stream configurations, fostering a very different set of storm types. So right now we're seeing many, many storms traversing the southeast US. That's to be expected with an El Nino. We also generally don't see very strong Arctic intrusions. El Nino winters tend to be very mild, okay? Irrespective of climate change, okay? So that's going to say that, well, we're going to get lots of rainstorms. We may still get snowstorms, but we're going to get lots of rainstorms. So you can almost think of it that, if you have an El Nino ongoing in the Pacific or a La Nina, it's a set of preconditions that then it's like the puppet master that's pulling the strings of the storminess that we'll get up here. And you can get very different suites of weather as a result. Well, the El Nino we have right now is showing signs of starting to dissipate, which may be a good thing. It may mean that March and April won't be entirely gloomy, laden with heavy rainstorms and maybe wet snowstorms. In 1983, I was in high school. March and April were the two wettest back-to-back months on record in New York City, 25 inches of rain in 2 months. It was dismal. Okay, I'd be very happy if we didn't have a repeat of that. So you can think of El Ninos and La Ninas the actual events take place in the tropical Pacific Ocean, but the effects of them radiate all around the world. They propagate because there's so much energy associated with it that enters the global atmosphere.
Mm-hmm. Great, great. Here's a very technical question. Are you concerned about the shutdown of the AMOC, given the most recent study? The AMOC, I just Googled while I was listening to you, the Atlantic Meridional Overturning Circulation.
Yeah.
What do you have to say about that?
Yeah, the AMOC is this deep ocean current that kind of comes to the surface, and in the Atlantic Ocean. It's very important in heat transfer throughout the Earth system. Okay, a lot of atmospheric heat ultimately enters the ocean and gets redistributed through things like the AMOC, which is not just distributing heat, it's also got gradients in salinity, the salt content of the ocean. Well, the AMOC is one of those things that brings warm water up into the North Atlantic Ocean. When I say warm, it's relatively warm, given how far north you are, okay? And that gives much of Northern Europe a relatively mild climate, okay? If you consider that much of Western Europe is at the latitudes of, say, Eastern Canada, well north of where we are, okay? The climate could be brutally cold up in a domain like that, much as it is in Eastern Canada. But instead, we tend to see very mild conditions there, largely because of the benefit of having these relatively warm ocean waters. If the AMOC shuts down, with the current actually sort of slows and eventually reconfigures to a different state, suddenly you won't be maintaining those mild ocean temperatures there, and a logical consequence of that would be a very serious downturn in temperatures in Northern Europe if that were to happen. There is reason to believe that this is something that has happened in the past, say during Ice Age periods, when you'd have a breakdown of this type of circulation. So nature already provides some kind of switching mechanism that will turn this on and off. It modulates it. We know that because it's happened historically in the past. The question is human-induced climate change now starting to interfere with something as fundamental as the AMOC? Okay. And if that is the case, what is the impact? Is it likely to intensify it or slow it down? That's such that it may, effectively collapse in the way that we see during an ice age. Well, there's some bothersome, you might say, modeling studies using very sophisticated oceanic and atmospheric models that suggest that one of the consequences may be, a disruption of the AMOC because of human effects on the climate, which would have enormous, enormous consequences to the world, because if you suddenly have such an abrupt climate change going on over Northern Europe, just think of all those economies that we're talking about and all the people potentially displaced. It could be, obviously of huge concern. This doesn't keep me awake at night. There are plenty of other things to keep me awake at night, but it is something to keep an eye on and certainly invest in the best science we can so we really can understand what the likelihood is of something like this happening. And if it was to happen, what is the timeline? How would it play out? Are there things we can anticipate about it?
Mm-hmm.
Yeah.
Thank you. I started my first question had to do with optimism. And my last question has to do with the reality, the increasing reality of despair, climate despair. We hear it from young people. We hear it all over the place. And I'm wondering, what advice do you have for those of us who are working on this? And I think most people on the call are active in many ways. Yeah.
Yeah, climate despair is obviously a very real thing. And it's easy to adopt an air of defeatism about these things. It's like, this is so out of control. And it's also painful because, even well-intentioned people ultimately, we're all involved in the consumption of fossil fuels because our entire system, the system that we live is based upon, say, transport involving fossil fuels, okay? It's very, very hard to avoid these things. Fossil fuels got us into this predicament. Well, the thing is, they got us into this predicament because, we're somewhat clueless, or, that when I say we, it's, our grandparents and our parents' generation to a certain degree. We had, several decades now where there's ample evidence and ample knowledge that we actually know that we have to move away from these things. One of the really interesting things, ways of looking at the situation that we're in right now is how climate change has shown us pathways to actually living better. All right. Would I have a big deck of solar panels on the roof of this house right now? Would I be thinking this way? The next vehicle that we get, we're waiting for our old, fossil fuel burning minivan to age out so we can get the gas electric hybrid, if not the fully electric vehicle, right? These are good things. Maybe we should have done it that much earlier. It would have been great if we were further along. But I think, living more in tune with the land, living more in tune with nature, recognizing the values of things like local agriculture versus, buying stuff that has to be shipped great distances around the world all the time. Um, there's some real benefits here. I think that on how we can become sort of better global citizens this way and live accordingly. So let's celebrate those things. They absolutely should be celebrated. And let's see how we can optimize and maximize that type of lifestyle change, and make it beneficial. Um, you know, weather is very dynamic, okay? Learn to enjoy dynamic weather, learn to appreciate it. Sometimes it can be scary. Obviously, there can be too much of it as well. But I think being in tune with the weather, and it's not just something that happens to us, okay? I think that that is, another way of appreciating these things. And also recognize that, as catastrophic as a flood in the Hudson Valley may be, look, they did occur in the past as well. It's worrisome that they're occurring, more frequently as we move forward in time. But guess what? As we make those investments and improve our infrastructure and improve the water retention capacity of the land, I think we'll see the benefits. Let's celebrate those things too.
Great. Well, we like to say at Partners for Climate Action, the antidote to despair is action. And certainly check out our website, look for our Instagram posts, and keep your eye on our next morning coffee series, March 12th. We'll send out an email to everybody. We have the head of environmental advocates. They are our leading advocates in Albany for those of us who care about climate and the state of the environment in general. Also, April 9th, Nathaniel Stinnett will be, he's the head of the Environmental Voter Project, and he will be talking about getting out the environmental vote in the Hudson Valley, in our bioregion. So keep your eyes up for those. Anton, just huge thanks to you for your willingness to do these. This was fascinating. And I know everybody on this call joins me in expressing gratitude. We will be posting a recording of this, and we'll be sending out a number of links for resources that have been discussed on the call. So thank you again, Anton. Thank you, everybody, for coming. This was really great. And we'll see you all next month.